Radiation is all around us, and that's not just because of cell phones and microwave ovens. Natural occurring isotopes all over the world give off different forms of radiation. Different forms of radiation, like the ones we have mentioned in our previous videos, affect us in different ways. To review the definition, radiation is a process where energetic particles or waves propagate through a medium. To better explain radiation, we're going to separate it into two main categories: ionizing and non-ionizing radiation. Radiation is ionizing when it has enough energy to remove an electron from the orbit of an atom or a molecule. Non-ionizing radiation does not have enough energy to cause an electron to be ejected, has less impact on an atom, and generally results in just an increase in energy for that atom. Some examples of sources of non-ionizing radiation are cell phones, AM and FM radios, microwave ovens, light bulbs, and sunlight. Sunlight for the most part consists of non-ionizing radiation. Gases in the atmosphere, like the ozone layer, are more likely to absorb ionizing radiation than non-ionizing radiation. Notice that the sources of non-ionizing radiation can be fairly common in our everyday lives. Similarly, ionizing radiation is all around us as well and comes from sources such as cosmic rays, X-rays, metals, energy production, and bananas. Some nuclei spontaneously emit radiation, and these are therefore labeled as radioactive. Some examples of a radioactive element are potassium, radium, and uranium. These elements emit some familiar forms of radiation: alpha particles, beta particles, gamma rays, and X-rays. X-rays are very similar to gamma rays, but they don't come from the nucleus, so we're not going to look into it in this video. Ionizing radiation has enough energy to remove an electron, and sometimes protons, from an atom, molecule, and the cells in our body. This damages the cell, and too much damage can be harmful. Our bodies are made to withstand certain amounts of radiation, and this is necessary because we also depend on radioactive nutrients like the beta-decaying potassium. Alpha decay would be particularly harmful to the cells inside our bodies, but they are unable to penetrate even our skin. This picture shows the ability of the three main radiation types penetrating common materials. You can see alpha particles are unable to penetrate most materials. Beta particles can easily be stopped, and certain gamma rays can penetrate even the most fortified barriers. There is still a great deal of information available about these types of radiation, and we hope that these videos have helped you in a better understanding of what radiation is. The better we understand radiation, the more we can benefit from the positive effects and prevent harmful damage. Thank you for watching.